All right, students, this is your very first flipped classroom lesson. This is Mr. Osborne, and we are just starting this out. I know it's mid-year, but hopefully we can do everything we're supposed to do with this. So a couple expectations. Like we said in class, you are going to want to watch the videos outside the classroom. That doesn't necessarily mean at home. It can be in the cafeteria before and after school, in the library. It can be in my room before or after school, wherever that might take place. You're just going to watch the videos outside of my classroom time. Make sure you're using your notebook. You're going to use your notebook to take notes and solve problems. Now, if you don't have your notebook at home today or wherever you're watching this, that's fine. Just use a piece of paper. But make sure you get that into your notebook. We're going to title each lesson, and the title of each lesson should be the title of your note page. Review the video as much as necessary to fully understand that. So what I mean by that is if you don't get it the first time, that's okay. Spend the time and get to know what the video is trying to teach you or what I'm trying to teach you. And when you come to class tomorrow, make sure you're fully ready to participate. Not only does that include doing the activity, whatever the activities we're going to do, that includes asking me questions of things you don't understand. So, our first lesson is on the Pythagorean Theorem. We are going to learn to use the Pythagorean Theorem and its converse to solve problems. That second part of that sentence is what we're going to do later. Today, we're just going to learn about the Pythagorean Theorem. So for this lesson, we have three words. Of course, one of them is Pythagorean Theorem. You've heard me say that a few times. Hopefully, you're starting to say that to yourself. If you haven't, say it right now. Pythagorean Theorem. The other two things we're going to learn is what is a leg and what is a hypotenuse. That word is pronounced hypotenuse. What I'd like you to do right now is in your notebook, go ahead and write down those three vocabulary words, and then as you learn what they are, you can fill that into your notebook. So here we go. The Pythagorean theorem states this sentence right here. In any right triangle, the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. And I know it's a lot of words, and it's very busy, but what I would really like you to concentrate on is this box right here. So if you need to, pause the video and copy this box into your notebook. Now, we have three sides of a right triangle. This has to be a right triangle. It's indicated by this square in the corner. That means that this is 90 degrees. Oops, not 90%, just 90 degrees. Let me start that over. 90 degrees. Okay? Now, in a right triangle, we have an A side, a B side, and a C side. And the A side and B side are called legs. The legs are the two sides that touch the right angle. And the way I learned this best one time is that the side that forms an L, if you look, this is an actual L. So L stands for legs. So the two sides that touch the L, or the two sides that touch the right angle, are the legs. The side that's across from the right angle, that does not touch the right angle, is called the hypotenuse, and we use the letter C for that. Now, the Pythagorean theorem says that a formula works where A squared, A times A, plus B squared, B times B, is going to equal C squared. Now, if you look at that in numbers in this middle box, what you see is that we have two legs. We have 8 and 6. And the hypotenuse is 10. And what the Pythagorean theorem says is every time in a right triangle, if I square the two legs, 6 squared and 8 squared, it has to equal the hypotenuse squared, the 10 squared. So 6 squared, or 6 times 6, is 36. 8 squared, 8 times 8, is 64. And 36 plus 64 better equal 10 squared or better equal 100. 10 squared is 100, which it does. And it happens every single time. So let's look at a couple examples of how you're going to use this. We have a right triangle here, and we have a 4 and a 5, and then we have a missing side that we called x. Now, we're going to use the Pythagorean theorem, and every single time we use the Pythagorean theorem, I want you to write down a squared plus b squared equals c squared. So you're going to write that down for every one of these problems. And then you're going to figure out, do I have two legs or do I have a hypotenuse or what do I have? And I'm just going to fill in the numbers. So the 4 and the 5 are both legs. The 4 is a leg because it touches the right angle. The 5 is a leg because it touches the right angle. And remember, right angles form an L, so these are our legs. Legs can either be A or B, and it doesn't matter which one you put it in for. So if one of the legs is 4, I'm going to put that in place of A, and that is 4 squared. Plus, 5 is the other leg, so I'm going to put that in for B and call that 5 squared. Now it doesn't matter, like I said before, it doesn't matter which one you put it in for. But C matters. C is always the hypotenuse. It's always that side that doesn't touch the right angle. So I don't know what this is, so I'm just going to put in x squared. And now I simplify this side so I can solve for x. Well, 4 squared is 4 times 4, so that's 16. Plus 5 squared, well, 5 squared is 25 equals x squared. I don't know what that is yet. That's what I'm trying to solve for. Well, I can add those two numbers together. That's pretty easy. 16 plus 25 is 41 equals x squared. Now, some kids like to stop right here, but I want to point out that this says x squared. It's not x by itself. Now, this is something we haven't done this year, but to get x by itself here, the last step always, actually, and that's probably a note you want to take, the last step always is to square root both sides. To get rid of this x squared, I have to take the square root of that. That gets rid of the squared. But if I take the square root of that side, I got to take the square root of this side. So this becomes x, and now I got to figure out what the square root of 41 is. That's actually not going to be very easy for you. You're going to need a calculator for this lesson. Hopefully you can have a phone or a computer or even a calculator at home, something where you can do the square root of 41. And I am going to find out, I'm going to use a calculator here at school, and square root of 41 is 6.40. Now I want to point out that it says round to the nearest hundredth, so I rounded it to 2 decimal spots. If it had said round to the nearest tenth, I would have rounded it to 1 decimal spot. And so now I know that x is 6.40. Okay? So now that I've done one for you, looking at that, I want you to try one on your own. Let's see how you do on this one right here. All right, so hopefully you had a chance to try that on your own. We'll see how you did here. Remember, I always want you to write a squared plus b squared equals c squared. That helps you fill in your formula. I fill in the two legs. The two legs are 5 and 7, so I put a 5 in for A. I put a 7 in for B. And I put the x in for C. Now I figure out what these are. 5 squared is 5 times 5, which is 25. 7 squared is 49, 7 times 7. Add those together. 25 and 49 gives me 74. And remember, the last step always is to square root both sides. So we got to take the square root of 74 and the square root of x squared. That leaves me with x equals, I type this in my calculator, the square root of 74 is 8.60. Remember that hundredths, I have to go to 2 decimal spots. Okay? Now, in both of these cases, we had to solve for the hypotenuse, but that's not always the case. Sometimes we have to solve for the leg. So, no different here. We're still going to write a squared plus b squared equals c squared. And I'm going to fill in what I know for the legs first. Well, I know my legs are 7 and x. Remember that the thing that makes an L, the thing that has a right angle on it, are my two legs. And it doesn't matter what order or how the triangle looks. It's always the right angle that has the legs. So I'm going to put in an x for A, but I got to put that squared on it, plus the 7, so 7 squared equals 25 squared. Now, simplifying everything, I got to do this 7 squared and this 25 squared. I don't know what x is, so I just bring that down. Well, 7 squared is 49, and 25 squared is 625. That's just something I know. If you need to use your calculator, I would do that. Okay, I got to get x by itself. So, unlike before, where I could just add these two numbers together, now I'm going to actually have to solve this. I got to get rid of this 49. How would I get rid of this 49? I have to subtract 49 on both sides. If I subtract 49 on both sides, the only thing left over here is x squared equals, and I'm actually going to use my calculator just to verify that 625 minus 49 is in fact 576. Now, last step always, square root both sides. And when I square root both sides, these cancel out. The square root and the square cancel out. That's why we're doing it. And we're left with x equals the square root of 576 is 24. It comes out to a nice, perfect number of 24. Okay? So pause that if you want to look at it. We're going to move on to the next problem where you're going to try one on your own here. Go ahead and try that one on your own and answer the question on Edpuzzle. Okay, you should have answered that question. Let's see how you did. We're doing a squared plus b squared equals c squared. And we fill in the legs first. So it looks like my legs, we'll see. Does this make an L? Nope. Does this make an L? No. This one makes an L. They really should have put the square in there so you knew that that was it, but that's okay. So we're going to put the x in for A. We're going to put the 4 in for B. And we're going to put the 12 in for C. Because the 12 is the hypotenuse, it doesn't touch the right angle. Okay, let's simplify this stuff. That's x squared plus 16. 4 times 4 is 16. 12 squared is 144. Got to get x by itself, so I subtract the 16 out on both sides. And I'm left with x squared equals 128. Let me verify that math. 144 minus 16 is 128. Remember that the last step always is to take the square root of both sides. So I'm going to find out that the square root of 128, square root of 128 is x equals 11.31. Okay? So that's how you're going to do these problems. I went through a couple of them kind of quick, and a couple of examples where you should have tried them. If you want to redo the video so you get another chance to look at it, great. But I'm going to expect that you have a pretty good understanding of this when you come into class tomorrow. Again, these should be in your notebooks. All 4 of these problems, 1, 2, 3, 4, should be in your notebook, as well as this note right here, so that you know what the legs are, what the hypotenuse is, and that the Pythagorean theorem is a squared plus b squared equals c squared. I'll see you in the morning. Have a good night, guys.